OSGi track. I'm glad you all got a seat. Um, so this morning we're starting with my colleagues Radu and Carl, who will be talking about using OSGi for script deployment with Apache Sling. Radu and Carl.
Right. Yes. Welcome to our talk. Who are we? Well, I guess
I can be your slide master actually after that. So I'm Radu Cotescu. I'm a computer scientist at Adobe. I work in the Basel office. I'm a member of the Apache Software Foundation. I'm also serving as a PMC member of the Apache Sling project. So if you're not really familiar with how the foundation works, a PMC, it's a project management committee, and it's the members who decide on releases or take important decisions for the project. It's a bit of just a higher status than just being a committer. And I'm also a maintainer of the HTML template language for Apache Sling. It was an Adobe effort to provide an open source templating language that allows you to build web components rendered server side initially, which is pretty clean. It only accepts HTML markup and some of the expressions in data attributes. And it was our effort to try to allow developers to write code for our platforms easier.
Right. And I'm Karl Pauls. I also work for Adobe and in Basel, but I'm based from Berlin, so I'm remote during the day. I am a long-time member of the Apache Software Foundation as well, and as such mostly involved with Apache Felix initially, and since a couple of years with Apache Sling now, that I started working for Adobe. And a while back I co-authored a book about OSGi as well. So Apache Sling, I'm not sure everybody in here knows it. So we have Carsten back in the back, who is one of the founding fathers of it. But it's a web framework for REST-centric web applications, which has a nice property that has an extensible content tree, and it's based completely on OSGi. So at the core, the real main idea is that you have this tree of content which is built up from OSGi services, so-called resource providers, which provide those resources for the tree. Right. So in a sense, you can think of it as a file system, and you have OSGi services which provide mounts. Right. So you mount them into different parts of the content tree. So then you end up with one consistent tree of content. Where typically, at least in the normal use cases, the root of that, so the underlying resource provider is JCR. In our case, Jackrabbit Oak. It's another Apache project, which is kind of the default or root file system, which is overlaid by other mounts in places, which are then free to bring their content from wherever they want to find it, remote or local, or make it up. But it's a reasonable complex OSGi system, and it serves underlying the Adobe Experience Manager, which is the product from Adobe which we are working on basically, and how that concretely works to map web requests to the content and render it. Radu will explain now in more detail.
So Sling is actually, initially, if you look at it, it doesn't look simple, but once you start working with it, it becomes really simple, and it's very intuitive how things are working. So if we would look how a URL actually gets mapped to a script or to a servlet and serves them content from the repository tree, this diagram should briefly explain it. We can start with a request. So we have a request for hot drinks, coffee, and we want a medium cup with milk. It's just a made-up URL. And Sling has this important, these important concepts of selectors in the URL. Obviously, we see the extension there, which is cup. And then we can also add fragments or suffixes. But then if you look at the request and you start analyzing it, each part of it is going to allow more specific mapping to the scripts that are going to serve that resource. So after we get the request, what Sling does is going to try to do a resource mapping. So it's going to try to figure out which resource from the content tree you're trying to access. In this case, the resource is basically the path, but we eliminate all the selectors and the extensions. So the path of the resource that we're identifying is going to be hot drink / coffee. Then we're going to find that into the content tree. It's going to be served by whatever resource provider is registered for that path, like Carl mentioned. And then the important thing about resources is that besides having a path, they also have a collection of properties. So if you'd like an abstraction, it would be like a file with metadata, more or less. And one of the metadata infos that we have on resources is this property called Sling resource type, which tells us what kind of a resource we're dealing with. So in this case, the resource is going to be of type coffee maker. And then we have to figure out which script or servlet is going to be able to serve this hot drinks coffee resource of type coffee maker. If we look only at scripts, when we do script resolution, what Sling does is it has by default some search paths, which are basically the paths where scripts are allowed to reside. By default, those are apps and libs, as you see later in the diagram. You can obviously configure that and extend it, but a nice property of those search paths is that they're overlayable. So if you look at a typical scenario with libs and apps, libs we consider it to be the default scripts provided by the platform, and apps would be the scripts that the user space is allowed to create, or that are created in the user space. And then a script from apps could overlay a script from libs, assuming that the relative path to the search path, so the relative path to apps or libs, is the same. So if I want to overlay the default libs coffee maker script, I just create another coffee maker script in apps. But that's more of a detail. It's not necessarily important for this talk, but that's how script resolution works. And then in those paths, we're going to start looking at the scripts provided. And what Sling is going to do is going to pick the most specific script. So we take all the scripts. We then have to figure out which ones are the actual ones that could provide the rendering. And then that is based on the combination between selectors and extensions provided in the original request. So if we look at the original request, we know that our resource is going to be served by the medium and milk selectors with a cup extension. So when we pick the actual scripts, we have to sort them in the order of their matching the URL. So we don't have a script for we don't have anything for the extension there, so then we can just use the selectors to pick up the scripts. So obviously the best matching script would be medium milk because it matches both selectors from the request. And then you just go into the decreasing order of their priority. So assuming you would not have a medium milk, then medium would be the one because it matches a selector. Coffee would match the resource type, actually the resource name. And then by default in a Sling instance, you also have the Sling get servlet, which is the default servlet to render something. In case there's no other specific servlet or script, then this servlet is going to kick in and is going to try to perform a rendering for you. After we selected the scripts and put them into order, then we have to validate that the actual script that had the highest priority is there and is going to be able to be executed. We read it. If it's a script, it's usually going to be interpreted by a script engine. And then depending on the script engine implementation, you either evaluate or compile. And then at the end, if it's compiled, you also have to execute. The difference comes is caused by the fact that some script engines implement compilable. So if they implement compilable, which is an API from the Java script package, then obviously you can store the compiled result, and then at next invocation is just re-executed. So that would be, a short day in the life of a Sling request. Now, I mentioned that rendering can also be done with servlets. And in Sling, scripts and servlets are equal, or they have more or less the same meaning for rendering a request. Difference is that with scripts, you have to place them into the repository or into the content tree at specific paths to make sure that they map to the resource types. So the path of the script is actually important in determining the resource type that the script is going to be able to serve. Whereas with servlets, we base the mapping onto some registration properties. The ones which are important in this on this slide, can you actually see it in the back? The contrast is okay here, but here it's hard, right?
Green is a bit hard.
The green is very hard here on the projector. Ah, that sucks. Let me try to actually change it for you live. We have plenty of time. Let's make everything white here. Yeah, sorry. The contrast was okay here, but okay, so let's talk about the registration properties. The ones which are really important to map the servlets to a resource type are Sling servlet resource types. It's technically an array, but it can also provide a single value. And then you can obviously provide the Sling servlet methods, Sling servlet selectors, Sling servlet extensions, and that's how you map them. When you provide the combination of resource type, method, selectors, and extension, you basically make the servlet registration more and more specific. So the more properties you add, the more specific the servlet registration is going to be. And it's obviously only going to kick in when the most specific request comes in. So it's not going to respond only because your resource has the resource type that you register the servlet with. You have to then match all the properties. So you have to have all the selectors and all the extension, or the extension, sorry, it's only one. This is an example of how we register the default get servlet, but it's similar for any other servlets that you would deploy. But obviously, as you've seen earlier, there's no standard way of defining versions or dependencies for these resource types. So there's no resource type concept that would map to a resource, or that would say script A is going to require script B at some point. Let's make sure that this is an explicit dependency. So by default in Sling, all the dependencies in between scripts are implicit. If a script is not going to be there, but another script requires it, most likely you're going to encounter an error. And the error is not going to be nice. Obviously, we're in the Java world, is going to be an exception. That's that, we have to live with it. We thought in the past, because Sling is an old project, of introducing resource type versioning through path conventions. And that worked and didn't. In the sense that the syntax was a bit complicated for the first version. We were just appending basically the version into the resource type after a semicolon, but it doesn't look that nice. The second option that it's now actually used in an Adobe project is that we're adding the version of a resource type into the resource types path. So as you've seen earlier, if we look at the resource type here, it was coffee maker. If you'd like to version it, you would do coffee maker /v1. And you would deploy the script into apps /coffee maker /v1. And then you have to create yet another coffee maker folder to make sure that it's picked up correctly by the script resolution mechanism. But again, that solves only half of the problem. It solves the versioning, but it doesn't solve the dependency. Again, there's not going to be an explicit dependency requirement. And as I mentioned earlier, then the dependencies can only be checked at runtime. So you cannot enforce them. You just start the application and figure out if it works or not. And then if you're working with multiple colleagues on a project, if one of you accidentally deletes a script that somebody else was delegating to, it's not easy to figure it out during the build process. You're only going to figure out once you actually start the whole application and figure out if you're lucky enough to have full integration and end-to-end tests, you're going to figure out that something was fishy there. Of course, if we're talking about scripts and servlets, and if you have a component that's composed of multiple scripts that delegate to each other and they're all rendering HTML, the markup can have semantic meaning, especially when you start to annotate it and put CSS selectors on it and so on. So even if you would change the whole markup in the script, you might still introduce a backwards compatibility problem for the people who depend on your script. Because if a CSS selector was changed in the meantime, then basically the whole aggregated component is not going to work as it did before this CSS selector change. And well, I'm not sure if it's necessarily fair to talk about performance, but it's also one of the aspects that that's important in the way Sling resolves scripts. So when you try to resolve a script or a servlet for a request, the first time when we do this, we're going to have to do 2 trips to the persistence layer. I'm going to show you again why. So first you have to go and read all the scripts which are there in the resource tree folder. You read them once, but you only read basically their paths. You're going to sort them. That's no read that you have to do. But then when you validate and pass it to the script engine, you do a second read. And then this time you actually read the script itself. Depending on the repository or the storage engine implementation, that might actually be slow or not. It really depends. With JCR, it's pretty fast because JCR runs locally, so it's in process. But if you have a resource provider that accesses a remote resource, doing 2 trips to a remote content engine might be slow, only to actually start rendering something. However, there are some caches that Sling maintains. So after the first resolution, the servlet or the script is going to be cached either into a servlet cache or into a script cache. And then subsequent invocations are not going to do the look around anymore, unless there's an event that's going to tell you that something changed in the tree. So if a new script is going to be deployed, or if you delete the script, or enhance the servlet, delete it, modify it, then the caches are going to be invalidated. But as we all know, there are only 2 hard things in computer science, right? Cache invalidation and naming things, or off by 1 errors, or we have just 1 joke and we always use it and it's kind of lame, but yeah. So we started to think about how scripts should actually be deployed. And then we started asking ourselves, are they content or code? In Sling, we say that everything is content, but it's not necessarily true, right? If you start putting scripts into the content tree, you're kind of mixing concerns. Then we ask ourselves, are scripts authored or developed? Because Sling basically is a CMS platform, and so is the enterprise product we sell on top of it. You have to ask yourself, do you author content when you're writing scripts, or do you actually develop an application? You use them freely, or do they have constraints because they have dependencies and requirements and so on? And then if they are code, then why do we treat them differently? Why do we put them into the content and there's no dependency resolution or versioning for them? So then we said, okay, if they are code, then they definitely actually provide or implement an API. If you deploy a servlet or a script, you basically implement an HTTP API. You say a request of this type is going to be rendered in this way. You create some expectations for somebody who's going to use your platform. Code also, we know that it evolves semantically, so you have to semantically version it. That means that you actually have to do something for the scripts. And code usually is bundled into cohesive unit, and it's managed by 1 or more developers. So then we should actually start treating them as such.
Right, and that that's where we got together and started to think about it a little bit differently and try to get OSGi involved more in that layer, because that's actually the weird disconnect a little bit in Sling. So yeah, it's already OSGi from the get-go when it was created, but that layer on top of it we did take little advantage of it, right? So the idea was to try to push the scripting parts into OSGi or into OSGi bundles. So that means on the one hand, for normal JSP scripts and things like that, but also for the more Sling specific ones like HTL, make that part of bundles, right? And get the whole idea of a resource type into that layer as well. So not only code dependencies like packages in the Java world. I mean, that makes some sense just immediately, but is there a way to actually push down the additional things like resource types and all these other things into the OSGi world, so that then we can take advantage of the OSGi framework, because that's what it was made for, at least in parts, to wire things together, right? And yes, there is. I mean, I'm not sure how familiar you are with that part of OSGi or not, but since a while we have this very nice thing that we extracted kind of from the code resolution and made it more generic, which is the requirements and capability model, right? So we take advantage of that. It's a layer on top of the code dependency resolution in a generic way, which allows you to define capabilities on the one hand, which can be your own semantics, your own meaning behind it, and then you can express requirements on it. But it matches the level that you have on the package level, right? So there you say, okay, I have a capability, which is a package I provide, and then I can require it. Right? Even so, for historical reasons, those headers are separate. I mean, you can express them in the resource and capability model. So we set out to do just that. So we created an extender pattern, or following the extender pattern, we created an extender, which sits there and waits for bundles to come along to wire to it, and then it's extending them if they have scripting capabilities or scripting requirements. Obviously, the requirements already help in that sense because OSGi will, during the resolution process, then help us already, because it just won't resolve bundles if they're missing something that they require. So we get that out of the box, and then we can use the introspection capabilities of the OSGi framework that they do on top of the requirements and capability model to work further inside the extender with it, right? So we don't have to do any of the parsing or the wiring up. We get the wired up result, and we can look at it and then sort of sprinkle semantic on top of the wiring based on what we understand about resource types, for example, and things like that. So and on the lower level, we also have scripts and that are, for example, JSPs, or that get compiled, as Radu said. So they generate actual Java code, right? So and then we use that part of OSGi too by just saying, well, they get explicit import package dependencies so that the bundles also get wired up on the Java code level correctly if you have precompiled scripts inside of the bundles. Which then is nice because we can create instances of Sling with wired up bundles that are checked, that they have the resource types they want in the right versions, that are checked for, that they have all the Java level dependencies for import packages and stuff like that they need for running as precompiled scripts. And we get most of that out of the box, and for the rest of it that we need to make work, we can use the OSGi API and the OSGi wiring result with the resource capability model from the resolver, and don't have to do all of that ourselves, basically. Which has simplified the stuff we have to do inside Sling. We don't necessarily need to use a script cache, at least for these bundles, because they come precompiled, they're wired up with a bundle, so then we don't need a script cache. We reduce the pressure on the persistence layer. As Radu explained, we do have to do less checks because of that. And it helped us to simplify, in some cases at least, the application upgrades because and deployment, because now you can look at the given deployment and say ahead of time, well, that will resolve or not. That's one benefit. And the other one is, well, once it is deployed and we want to update something during the runtime, OSGi can help us with that, right? Because we just update the bundle and it will update all the transitive closure over its dependencies and rewire everything, which previously needed to be done by Sling as a system itself in a somewhat heavy-handed way. So that can help with that. And ultimately, yeah, we created a Maven plugin too for generating the requirements and capabilities out of script naming conventions. So if you have scripts in our system and you name them correctly or put them in the correct path and put the Maven plugin into your POM, it will generate those things for you as well. How that changed landscape then looks, Radu is going to explain again.
So if we take the previous diagram that we showed with the script resolution and put it into the context of scripts fact as bundle entries or as precompiled scripts into bundles, we still do the same resource mapping as we had before. We figure out the resource type, but instead of going to the persistence or to the content tree and figure out which are the best scripts to select for this request. We're just going to have a servlet that's going to be mapped to the resource types that were identified by the script in the project. The servlet is going to be registered based on the provide and require capabilities that we talked about earlier, and we're going to have some examples later in the presentation. And then what happens is that in case the scripts are packed as they are, so they're not precompiled, it's just source code. In case we pack them as bundle entries, what happens is that for each provide and require for each provide capability, we're going to register a servlet, and then this servlet is going to have access to the bundle from which the scripts come. And then the servlet is going to perform the script resolution directly from the bundle. So this is going to happen from the bundle space. It's obviously way faster than going to remote systems to retrieve scripts and read trees. The servlet then is going to select the script and try, depending on the script engine that's going to evaluate it, either evaluate it or compile and execute. If it compiles it, obviously it can store a executable unit, we call it. It's going to be cached then in the servlet, and then at the next invocation is just going to use this compilable unit or this executable unit and just serve the response. If we decide to precompile scripts, the bundle looks more or less the same, except that it's going to provide classes. The servlet is going to again know which class matches best to a certain request. It's going to select exactly that class, and then as I said before, it's going to select it, execute it, cache an instance of that class, and then at subsequent invocation is just going to execute it, and then it sends the response. So how does it work in practice? The blue and the green rectangles are basically bundles. Let's assume that we have a coffee maker and a latte art maker. And the latte art maker is just a specific type of coffee maker, right? It does coffee, but it adds some latte or some milk into your coffee. And then obviously it needs all the knowledge of the coffee maker to be able to provide you with a drink. They both provide scripts, and then they both provide and require capabilities. The coffee maker, because it doesn't have any dependencies, it just wires itself to the to the bundle scripting tracker by using this explicit require capability. It says that it needs Sling scripting extender in a certain version range. But then the latte art maker, which actually extends the coffee maker, not only that is going to explicitly require the bundle tracker to be present, but it's also going to require a coffee maker resource type in a certain version range. And then because they both wire themselves to the bundle tracker, then the bundle tracker is going to handle the servlet registrations for them so that they can start serving requests. And then the bundle tracker is going to use each bundle's context to correctly register the servlets. It's going to be one servlet registration per provide capability. However, in case you're overriding or overlaying something from a bundle, then we're going to also provide some, we call them shadow registrations, where you just dispatch what happens when you overlay something. So when you overlay, you have the option to completely overlay a script, or in case you want to overlay only some scripts, you overlay those scripts, but then what you don't have is going to be dispatched to the resource type that you're overlaying. So if you have scripts A, B, C, and then in the second bundle you only have C, but C uses A and B, when it delegates to the previous ones, it's just going to use the ones deployed by the original bundle. And then we're going to end up with this servlet registration. And as I said before, for each provide capability, we have one servlet. A provide capability is relatively simple, or in a very simple case, it is simple. We just identify the resource type that we want to register the servlet for. We say that the servlet is going to answer to the get method, and we declare the version with which we export the resource type. Obviously, when you have multiple scripts and you want to use different methods or a selection of methods or multiple selectors, or you add extensions, the provide capabilities become a bit more complex. Hence why we wrote this Maven plugin, which reads the structure of your bundle in the file system and then generates the provide and require capabilities for you. So let's switch to a quick demo. We're first going to start with with how the code looks like. So we have two components, actually two bundles, a bundle that provides a page component and a bundle that provides an extended component. We have regular HTML scripts, which look like HTML, nothing fancy about it. And then if you look at the project structure on the left, what you see here in the script section is basically we're saying that, okay, we're going to expose a resource type, which is going to be the name of that package. So Sling mini demo page. We're going to expose it in version 1, and it has those scripts. When we extend it into a different bundle, again, this other bundle exposes a different resource type. It's also in version 1. It overlays some of the scripts. So in this case, it overlays head. But what it also says into an extents file, maybe I can actually zoom it a bit. Can I do this? Yeah, okay, sorry. I could switch to presentation mode, but that's actually the last thing that I want to show from the code. So in this extends file, which is a meta file, we just say we're going to extend the Sling mini demo page resource type, but we expect that this resource type is going to be in version 1 until 2. We're kind of using the version semantics for it that we're familiar with from the OSGi world. And obviously, this is going to generate a require capability. We talked earlier about a Maven plugin that we wrote to generate the provide and require capabilities. This would be a configuration of it. We just specify where our scripts are on the file system, and we just generate the metadata. And the metadata is going to be appended to some properties, which you can use during build time. And we're using the BND Maven plugin to generate bundles, so we just add our properties into the provide and require capability headers. And the require capability, a bundle would have to explicitly mention that it needs to use the bundle tracker, which is what this require capability does here that I selected. But then obviously the Maven plugin that we wrote is also going to add the additional require capabilities in case we're extending or overriding another resource type. And then there's another meta information in case we're using precompiled scripts. You have to add this information for the scripting bundle tracker so that it knows it works with precompiled scripts. And now I'm going to show you a quick demo. What happens with a resolution when things go correctly and when things go bad. So I already started an application here. This is the one where everything is deployed correctly. We have the two bundles that I showed you earlier. So there's one bundle which provides the page resource type in version 1, and there's obviously another one which provides the coffee components. They're also in version 0.0.1. So everything is wired correctly. All the bundles are running. If I go and render my application, it might be a bit slow because this is an implementation on top of Dropbox where we get the content from, and the first request has to be cached. But you're going to see that the rendering works. So it re-rendered, and now everything is cached. But then if we would go and stop this application and start one where the page component is deployed in version 2. Let me just stop the previous one. Okay, let's use the second version of the app to start. And I'm just going to grab the logs by the error message. It's going to take a bit until Docker does its magic. So we already see the error here. In this case, we deployed the page component in version 2, but Coffee expected the page resource type in version 1 until 2. We already see a resolve error. The Coffee bundle is in resolve state because it cannot actually resolve one of its requirements. If we go back to the system console and refresh the bundle state, we see that the Coffee bundle is installed. Right now, the Felix console doesn't display errors when it comes to not being able to resolve a bundle due to its requirements. So it's only going to show you an error if a package import is missing. But the errors are actually logged. And then if I try to go and render again the application, It's again going to go to Dropbox to try to get the resource, but then you see that the rendering actually doesn't work. It's going to be served by the default servlet.
Right. So we're coming to an end here. Just want to mention that while not the initial motivation as such, I mean the nice thing about pushing down the scripting stuff, at least in the precompiled case, is that we are also hoping that we can leverage the new OSGi RFP 196 that's going on, which is called OSGi Connect, and is trying to make it simpler, or at least possible, to ahead of time compile OSGi-based Java applications. So, and with our precompiled scripts and the wiring that we have now on the OSGi level, we hope that we also can take advantage of that in combination to create native images out of Sling and Sling scripts. But that's just future work basically at this point. And with that, I think we're done. The resources are all there. I think the demo that Rado gave is on GitHub. You can find the links in that page. And I think that's it.